Alright, so let's talk about chi-square test for independence. Let me divide this into half. Okay, so let's do an example. So let's sample 100 people and ask them whether they like dogs, are neutral about dogs, they dislike dogs, and same thing about cats. So we have a 3x3 chart. We have like dogs, neutral about dogs, hate dogs, and those are the columns, and the rows are like cats, neutral about cats, and hate cats. And the numbers are 25, 4, 11, 3, 3, 4, 42, 3, 5. Okay, so we want to decide whether the rows and the columns are independent or not. So you want to be able to conclude that liking dog and liking cat are dependent, which means whether you like dogs affects the probability of whether you like cats, and H naught is the opposite. So it's the same statement except they are independent. Okay, so this original chart is the observed value. Okay, so we want to construct a chart for expected value. And because our chi-square should equal to the sum of O minus E squared over E. So we need to first calculate expected values for the 9 entries. So let me okay. So what we're gonna do first, we're gonna sum the row and columns together. So if you add the rows together, this is 40, this is 10, this is 50. And because total is 100 people, so 40 is 40% of people, and 10 is 10% of people, 50 is 50% of people, which is nice. So let's copy that here. So 40%, 10%, and 50%. And let's do the same thing for the columns. So the first column is 80, 70, 70, which means 70%, 10, which means 10%, 20, which means 20%. So the columns are 70%, 10%, and 20%. All right, so to figure out the expected values, what we do is, so let's see, for the top left entry, it corresponds to 40% and 70%. So this entry should have expected value equal to 40% times 70%, which is 28%. Again, in this case, it's easy because there are 100 people in total, so 28% is just 28. And the same thing for all the other entries. So the top middle is 40% times 10%, which is 4%, which means 4. Okay, so this is gonna be 8, 7, 1, 2, 35, and 5, and 10. Okay, so that's our chart for expected values, and we can calculate the value for chi-squares. So the chi-square is equal to O minus E squared over E for all 9 entries. So this is equal to 25 minus 28 square over 28, top left, 4 minus 4 square over 4, top middle. I'm not going to write down all the 9 entries. And then bottom right is 5 minus 10 square over 10. If you use a calculator, this is equal to 14.4321. So that's our values for chi-square, and we also need the degree of freedom. So the degree of freedom is equal to the number of rows minus 1 times the number of columns minus 1. So in this case, we have 3 rows and 3 columns. So number of rows minus 1 times the number of columns minus 1 is 4. So chi-square is 14 times 14.4321, and degree of freedom is 4. Now we look for the table, which is hidden here. All right, so degree of freedom is 4. So we look for here. 14.4321 is between these two numbers. So that means our p-value is between these two numbers. So that means p is between 0.01 and 0.005. In particular, p is less than 0.05, so that means we can reject h naught at 5% level and conclude that liking dog and liking cats are dependent.